Hello everyone, it's Craig Maynard again, and this time we're going to explore some Ethernet communications. And what I'd like to do is talk about a way of getting information from your Allen Bradley, Compact Logix, or Control Logix PLC over to the ABB robots. If you want to pass information about an X or a Y value for the vision system told you, or give some information from the PLC to the robot, you got to get the data over there. We're going to use Ethernet to do it. Now, the manual that I use to teach myself this is this Ethernet IP scanner adapter manual from ABB. And if you move down into it, there's installing and configuring Ethernet devices. This was the step-by-step guide I went through to configure the ABB robots to do our bidding. Alright, so the first thing we're going to do is let's open up a Studio 5000 session and hook it up to our PLC. Okay, so we'll just do a new project right here, and let's open up a Compact Logix system, QBFC1B to ABB. We'll call it Ethernet to ABB, and revision 30 is fine, and we'll bring up our session. And a moment later, we find ourselves booting up. And at this point, I'm going to find a PLC and I'm going to connect to it, and we should be on our way. So we're going to go here, go to Ethernet IP. I'll find an unused system. Let's say, I don't know, we'll choose system 15, and we'll connect to that one. And download was just to make sure that we actually have good communications with station 15. Yeah, looks like we're connected. Yeah, no problem. Okay, so first thing we have to do is go offline. Now that we're in run mode, we're going to go offline, and we're going to add in an Ethernet module, the Ethernet adapter for the ABB robot. Now to do that, we're going to go down to the Ethernet, and we're going to add in a new module. Okay, and the module we're going to load in is just the generic Ethernet module. So probably just best to search generic Ethernet module, generic Ethernet module. There we go. And we'll just create that. Now we have to give it some information. Give it a name. So I'll say ABB Ethernet interface. Sounds good. This is and we'll just give it a little description because I love commenting. This is the connection to our ABB robot. And this is an IRB 140. So, what the heck? IRB-140 robot. Now, all the communications between the PLC and the ABB have to operate on a byte format. Now, the Allen Bradleys tend to want to use DINTs, which are 32 bits, but everything on the robot is 8 bits, so we're going to have to set this for a SINT, a single integer. Okay, so make sure that communication format is single integers, 8 bits right here. And in the IP address, it'll be the IP address of the robot that you're going to be talking to. Now, our particular one, I'm just looking at the robot right now, and it says it's 10.165.13.6. That's our robot. Okay. And we have to also set up the assembly instance for the robot itself. Now, the assembly instance is where in memory it's going to find these 8-bit blocks. Okay, so the input address for the input bytes are going to be at location 100, and I have set up the ABB robot to have 16 8-bit bytes available to you. And you could probably put more in, but for now we have 16 8-bit bytes. That's 8 32-bit bytes available. And the output, we always set that for 112, and there should be 16 8-bit bytes there as well. The configuration, you have to put something in there, so I'm going to say there's 1 byte, it's in location 1, and it's 0 bytes. We're not actually using any configuration. Okay, so where did this number 16 and 16 come from? Well, I'm going to move over to the robot for a second. So let's go here, and we'll bring up Robot Studio next. So I'm going to bring up Robot Studio version 6.05. And in a moment, we're going to come up with our robot, and we're going to create, I don't know, solution with station and robot controller. Sounds good. Now we're going to call it Ethernet connection to PLC, to Allen Bradley PLC. Okay, and it's going to be an IRB 140, so let's just choose one of those. IRB 140T, robotware 6.05, everything's looking good. Let's just create that. And in a few moments, we should have a robot show up here. Okay, and now after a few moments, our controller status is green, and we have a robot hooked up. We're ready to go. This is our simulation of a robot, right? So we can use this just like we've been working with simulations all over in this course. Now, in this case, we want to actually connect to our real robot, not the simulated one, but a real robot. So let's go to the controller, and we're going to add a controller in there. So if I say add controller, we'll do a one-click connect, and we have to make sure we're actually connected to the Ethernet port. So add controller, we'll just do an add controller then. And at this pace, we'll choose the robot we want to connect to. And our robot was 10.165.13.6. We call it HAL. Okay, so we're going to say connect to that robot, and now you can see there's the real system right there. This is the real robot, and this is the simulated robot, right? Which we really don't need. Close that all up right there. Okay, so now, and now we're in the real robot right here. So let's go into configuration on the robot, and we're going to look at the I/O system. And we're going to look at the industrial network right here, which we're going to be working with. We're going to be communicating on Ethernet IP, this public network. This is our scanner adapter network that we're going to use to communicate with our robot. If we go to the Ethernet device, or Ethernet internal device, Ethernet IP internal device, you can see here the name of the device is Ethernet internal device. It's connected to Ethernet IP from ABB Robotics, and the connection size in bytes is 16, and its output size is 16. Now I could change this. I could make it larger or smaller if I choose to. To change it, I would have to request write access, and once I request write access, I'll have to go over to my teaching pendant and press the grant push button on there to give you that access. It'll pop up on the screen. And then I could change these numbers to whatever I want. But I've preset mine to 16 and 16 bytes. That should be enough to get quite a bit of information back and forth. So 16 and 16, that's where these numbers come from, 16 and 16. So we'll say OK. And requested packet interval, 10 milliseconds is fine. I wouldn't use unicast. I would just let it broadcast. It seems to work best for me. And we'll just apply that, and we'll say OK. Now, there's our Ethernet module for the ABB. Let's actually go online and see how it works. So I'm going to download at this point. And we're finalizing download, and we're going to go back to remote run right now. All right, so just a moment ago, when it first came up, I noticed a little triangle showed up on the Ethernet module. It didn't connect right away, and I was wondering what the world was going on. So I paused it, this recording, and I started it back up again. And the problem was, when I went to connections, it said there is another PLC that was already connected to the Allen Bradley. So what had happened was I had tested this program on a second PLC. I had connected it to the Allen Bradley, and it was still running, so it was still connected. So what I did was I went and turned it off, so it was no longer connected. Another thing that might be worth mentioning here is this requested packet interval. This is how long it is between packets between the PLC and the Allen Bradley. So every 10 milliseconds, it's going to be asking for another update, So it's 10 milliseconds. That's 100 times a second. And that's not so bad, but if you find your traffic is getting a little high and you only need to maybe pull your inputs every half a second or every second, it doesn't have to be down to the very small intervals of time. You could increase this to something like 50 milliseconds if you wanted to. But anyways, I can see right here my Ethernet is working. I am in run mode, and my Ethernet module is not giving me any problems. I'll just apply that, and we'll say OK. And it looks like we're good. Now, if you notice now that we have created that data type, you go to the controller tags, and you now notice there are 3 new tags put in there. ABB Ethernet Interface I for input, ABB Ethernet Interface O for outputs. So you can see right here, the Ethernet inputs have got 0 to 15 since. There's my 16 bytes that are being sent to the robot. And over here, ABB Internet Interface Output shows me 0 to 15 since again, which are my outputs. Right? So those are going to be, this is where the data is going to show up and go to our robot back and forth. Okay, so let's go back to the robot side over here. We'll look at our robot side. And I have taken this Ethernet internal input, this Ethernet IP thing, and to make it more convenient, I'm breaking it into groups. So if you were to go to the industrial network right here, go down to your I/O system, and look at Ethernet IP, and look at the Ethernet internal device that we have right there. You can see I've set up 8 groups, 4 bytes of input, Ethernet input, and this one here is bit 0 through 7. The next one's bit 8 through 15, 16 through 23, and 24 through 31. So there's 4 bytes or 2 DINTs for inputs. I've also got 4 bytes or 2 DINTs for outputs right here as well. And we're ready to transmit. So let's have a look here. So on the ABB side, if I was to take one of my outputs, let's take my output right here, data bit 0, and this is a synth. So let me put a number in here. I'll put in a number like 128, for instance. Oops, it looks like I've got something other than a number in there. I'll type 128 without putting a left bracket. Okay, now there was another configuration error that I get to share with you. Notice when I went to my second byte right here and I tried to send it out to the robot, it didn't work. Let's see if I go to here and the second byte and try to set it up and send it out. It says I can't send the I/O value. The access level of this signal is not allowed changing. Now, when I created these groups earlier on over in the I/O system, you'll notice that the 0 to 7 I had access level for all, but for the other bytes I set them to default. So I'm going to have to go in here eventually, request write access for the robot, and change these to all for these 3 remaining groups, and that should have fixed that problem up. But I'm going to leave that to a later date. You guys can work with that on your own. Otherwise, that's basically how you do it. That's how you get data input and output to the ABB robots. Good luck.